The first thing you need to do is you need to go to aplusstudents.com. Okay, you go to the website and you select math as your subject. You select math as your subject. This is a lesson for grade 10s. And the topic for today is parallel and perpendicular lines. Perpendicular lines. Okay. And I'll give you the chapter and the lesson. The chapter is 26 and the lesson number is 7. Chapter is 26 and the lesson number is 7. It's continuation of the last lesson that we did. We will be considering more proofs today. Okay. Proofs involving parallel lines. And this is the continuation, the second. Okay. So once we are in grade 10s, we have logged into the website. We are in grade 10s, chapter number 26 and lesson number 7. Okay, let's start off with the first question. Complete the proof that this is given to us. We need to see the proof, what exactly we can do with this question. Okay, so the first question that we have says this. We need to complete the proof for question number 1. It says a shape is given to us. Okay, I'll just redraw, resize so that, okay. They're saying that the angle T, we have lines over here. We can always extend the meters to us, okay? Two are parallel lines that are us. In the second statement, it's given, okay? Angle T, it is also given that this angle WTX is equals to this angle, okay? That means this is XVUX, right? This is also given to us. What we need to remember here is whenever we have a pair of two parallel lines and we can see an alphabet Z is being formed, right? A Z is being created with the parallel lines, then these two angles would always be the same, okay? Okay, moving on ahead, let's see what we can do here. The next statement says angle T is equals to angle U and they are alternate angles. Okay. The third statement, the next statement says VUX. Where is VUX? This angle is alternate interior angles, right? The same statement. Okay. Angle T, this given angle T is equals to TWX. They're saying that TWX, they're saying that these two angles are also same, right? That is the transitive property of congruence. Congruence is exactly the same, okay? Now what we need to see is what happens with the last property, TWX. TWX, this given angle, they're saying it's equals to angle V, okay? So we know that whenever we had parallel lines, we said that these two angles were equal, right? Do we agree? That means if we have another set of parallel line that is passing through this part over here, we know that the angles at the center are always equal, right? vertically opposite angles, then the angle at this point should be equal to this. Okay, so the name of this property is same, transitive. It's exactly the same as the previous one, this one, and this is exact transitive property of congruence. Congruence means exactly the same. The term congruent in mathematics means exactly same, okay? Not similar. Similar will be in ratios. Congruent is exactly same, okay? So we just had to give this property over here, transitive property of congruence, okay? The next question we have is we have more than two parallel lines. Let's see if we have more than two parallel lines. How can we do the question? Okay, let's just keep it here. Let's see what property can be applied in question number 2. The question number 2 states that we have FH. FH is parallel to WU. The first statement, it is given. The next one is given as FH is parallel to RT. This line is RT. This is also given to us. What they are saying is the angle QSR. Let's try to find the angle QSR. Where is Q? Q, S, and R. This given angle F, G, Q. F, G, and Q, right? We know that whenever we have, I'll just draw, whenever we have an alphabet F being formed somewhere, there would be corresponding angles. We can see the shape of F being formed over here, right? That means they are corresponding angles. We try to find different alphabets, sometimes U, sometimes Z, sometimes S, sometimes T, F. F, these two angles which have been marked in green are corresponding angles to each other. That is already given in the question, right? This angle and this angle are corresponding angles. So the next part of the question says FGQ, FGQ, this given angle plus UVX. Where is UVX? U, V, and X. This given angle, right? They are saying when these two angles, this angle and this angle, okay, they are added together, the sum of these two angles would be 180, supplementary, right? Supplementary angles. Let's see how is it possible. Can we draw a single line, QX, okay, and we draw two pairs of parallel lines, one line and the second line over here. What we can say is if this angle was X, then this angle would be X. In order to find this angle, can we say 180 minus X? Then this angle would also be corresponding, and this would be 180 minus X. Where we can, now what we can say is the sum of these two angles is always 180. Agreed? The given sum of these two angles would be 180 over here. Same way 180 over here. That means if this was X and this was 180 minus X, then this would be 180 minus X because these two angles are corresponding. Agreed? Then the sum of these two angles would be 180. And we say same side exterior angles, right? Because they are on a line that is intersecting two parallel lines. Okay, since these two were parallel. So let's look at the last one. In the last one, they are saying that the angle QSR. Let's label QSR. Where is Q, Q, S, and R? This angle QSR. This is Q, this is S and R, plus UVX. U, V, and X. Okay. They are saying they sum up to 180. Why? Because if this angle was X, then this is X. Then this is 180 minus X. And this is X also. So what we can say is, it is true that these two angles would sum up to 180. And this property is known as substitution, right? It's known as substitution. That means the sum of the two angles would be 180 supplementary angles. Do we agree till here? Any questions up till now? If there are any questions, please let me know. Okay, good. Let's try another example. Let's see what they're asking us in the next question. The question number 3 states that complete the proof that these two angles are same. Okay, let's just do it over here. Question number 3. And this is the given information for question number 3. This is our question number 3. What they are saying is we have two pairs of parallel lines. I'll just re-highlight these parallel lines over here. If these were our parallel lines, what they are saying that complete the proof that angle Q, let's highlight angle Q. This is the angle Q is equals to QRT. Very similar to our previous question, question number 1 that we did over here. We saw that these angles were same, right? So in question number 3, most probably we'll have the same property, transitive property. Let's see what properties are given to us in the question. They are saying that angle P is equals to PST, right? Angle P is equals to angle S. Agreed? It's given to us. The lines are parallel, it's given to us. We know that whenever we are forming a Z, angle P and QRT, angle P, QRT, that means it can be written as QRT or it can also be written as QRV. That means it's the same angle because R, T and P are points on the same line, and the points on the same line are also known as collinear points, right? So RTP are collinear points. So we can say QRT or QRP, it would still say be the same angle. Okay. Moving ahead, let's see what else. QPST. Angle Q was equals to PST or PSQ. Okay, they're alternate interior angles because it's forming a Z. I'll show it to you how. If these were the two parallel lines we had, and we had a line intersecting over here, we can see a formation of an N or a Z. In this case, these two angles would always be same. Interior, alternate interior angles. Okay, agreed? Moving to the last, they say angle P is equals to angle Q. And they're saying they are still alternate angle. Oh no, transitive property of congruence. Let's look at the transitive property of congruence. Sorry. Angle P, this angle P is equals to Q. Okay. Now remember one thing. Whenever we are looking for transitive property, if we have a pair of parallel lines, I'll make it very simple, right? And we say that we have two pairs of lines intersecting, right? So whenever we see this shape that is forming a butterfly, right? Easy words to remember. That would mean that the angles at the base, sorry, the angles at the base, if this is angle X, this would be X, right? And if this is Y, this would be. But in this case, they both were equal, right? So we can write X and X, all four angles to be X, right? So what they're saying over here is Q, angle Q, let's highlight angle Q and QRT. Where is QRT and this angle, right? So whenever, if these two angles were same, right? If they had the same value, what do we call them? They were transitive property of congruence, like the statement number 5. So do we agree that the statement number 5 and statement number 6 are referring to the same logic, right? So if they are referring to the same thing, that means the same property is being applied. Okay. Let's look at question number 4. If we do question number 4, the question number 4 has, okay, I'll copy the question, then we'll do it together. And it says, question number 4 is on the screen, and we have this. Okay. So question number 4 over here says, complete the proof that Hij, Hi, and J is equal to G, H, I. Okay. That is G, H, I, right? But what they did in the question is they have marked this angle. And it's quite simple. Why? Because if we have a pair of parallel, I'll just show it to you. If we had a pair of parallel lines that was being intersected by a line at the bottom, right? We already know that if we had these parallel lines, then we know that these two angles are already equal. So if this angle was X and they are saying this is X, then this has to be X, right? X is a random angle. We are just labeling it as a variable, okay? For the first statement, they say HI is parallel to GJ. Let's see the first statement. HI was parallel to GJ. This is already given to us. Okay. This is given to us. They are parallels. It's given already. Hij, whereas Hij, this angle, FGJ, F, G, and J. We just saw that, right? That these two angles would be same. It's given to us. The next one is GHI. GHI. This angle given to us. would be a corresponding angle to FGJ, right? These are corresponding angles. Agreed on this. So what about the last one? If we have HIJ, let's label. If we had HIJ, where is HI? HI and J, this angle, GHI, GHI, right? This angle. So for this condition, it would be known as transitive property of congruence, right? They are equal with the transitive property of congruence, which is exactly the same thing we saw in the previous question, question number 3. So we are just looking at a few of the properties that would give us the reasoning why these two angles are equal. Okay. Moving ahead to the next question, question number 5. Let me just copy this. Okay. For the next question, it says, I'll draw it down there. Okay. The question number 5 says, if these are given to us, okay, these values are given to us. This is question number 5. What they are saying is we have 3 pairs of parallel lines. Okay. Parallel and parallel. Okay. So what we saw over here was they made 2 arrows showing that these 2 lines are parallel, and they made single arrow sh showing to us that this line is parallel to this. If A was parallel to the line C and line A was parallel to line B, then the line B and line C were also be parallel, right? They would never intersect. Okay, what they are saying is, 1 minute please, let me just have a look. RT and EG. Where is RT? RT and EG. Yeah, they're parallel lines. This line is parallel to this line, right? The next one is this UW. This line is parallel to EG, is also parallel to this line. That means all 3 lines are parallel to each other. Moving ahead, it says QW, QVW, where is Q, V, and W, this angle, GFQ, GF and Q, this angle. And we know that whenever we see a formation of the alphabet F, I'll use a brighter color. Whenever we see a formation of the alphabet F, right? Can we see F being formed over here? Then this angle and this angle would be same if only these 2 lines were parallel, right? So we can say we agree that these are corresponding angles. Let's look at the alternate. GFQ. GFQ, where is GFQ? GFQ, if this angle is equals to RSX, RS and X, this angle, right? That means if we have 2 pairs of parallel lines, okay, and they are being intersected by another line, then this interior angle would be equal to this alternate interior angles. We do agree on this, right? If this was X, then this would be X. Agreed? Okay. And the last option that we have is they're asking us to show QWY, QVW, this angle QVW is equals to R S and X. RSX is equals to this angle, right? They're asking us to show that this angle would be equal to this angle. And the property is known as, if angle F and angle S were equal, okay, I'll highlight. If these two angles were equal and these two angles were equal, then these two would be equal as well, right? And the property is known as transitive property of congruence. If A equals to C, see, it would be stated like this. If A equals to C and A equals to B, then B is also equals to C, right? That is the transitive property of congruence to find the angles in a given question, okay? Moving ahead to the next question, question number 6. Question number 6 says, complete the proof that these are the given conditions. Let me just copy this. For question number 6, it says this, and let's see. This is our question number 6, okay? So over here, they're again saying the same thing. If Vx and Hj, let's see, Vx, right? Vx and Hj, if the line B and C are parallel to each other, then the lines Su and Hj, if the line 1 is parallel to line 3. Agreed? First they said that if this is line A, B, and C, if they said line, sorry, if line B is parallel to line C and A is parallel to line C, then C would be parallel to, sorry, B would be parallel to A. Agreed? These are the properties that we are given. The next one is the angle RTS. Where is RTS? This given angle. And HIR. Where is HI and R? This angle is given to us. Let's look at the formation of what is exactly we can see over here. If these were the two parallel lines given to us, and if I would say we had a line intersecting this, what they are saying is that these two angles are same. Can we see the formation of the alphabet F over here? Agreed? And whenever the alphabet is being formed, that if this is X, then this is X, and these angles would be known as corresponding angles. Agreed? Okay, moving ahead, they're saying that HIR, whereas HI, and R, this given angle is equals to RWV. R, W, and V is equals to this. Same statement. Corresponding angles. We can see the formation of the alphabet F over here because we have pairs of parallel lines over here. The next one is RTS, whereas R, T, and S, if this given angle RTS, R, W, V, yes, agreed. If, okay, in these cases, if T was equals to I, right? And I was equals to W, right? Then can we say the angle T equals to, whenever we have a comparison for three angles or three parallel lines, we say that it is a transitive property of congruence. Okay, these are the angles. Angle T was equals to angle I. If I was equals to angle W, then T and W would also be equal. That is the transitive property. The last statement that they want us to give the reasoning is Vx is parallel Vx is parallel to SU. Let's see. Where is Vx? We can say Vx is parallel to SU. Okay. Keeping in mind the first two properties that we had, which we proved over here. If the line B was, okay, I'll just write down again over here. Bx was line B, is if the line B was parallel to line C, okay, and SU was line A was parallel to line C, then Vx is line B is parallel to SU. SU is line A. Agreed? So for these conditions, whenever it's a repetition, right? So we would say, see, when we were doing the angles, it's a transitive property of convergence, right? And then we have, whenever the lines are like that, we would say converse. The name of the property is of corresponding angles postulates. Okay. So we are just trying to show and we are trying to prove that the conditions given over here, whether they are true or not. Okay. Any questions? Okay, let's try one more. And the next question that we have is again a set of three parallel lines. And we'll see what we can do with parallel lines over here. Question number 7. I'll just move ahead. If this is our given question number 7, and in question number 7 it says, e.g., okay, if I label this as A parallel line, B parallel line, and C parallel line, e.g. is A, line A is parallel to UW, is parallel to line C, it's already given in the question. RT, that is line B, is parallel to EG. EG is line A, right? If these two conditions are met, then can we say that? Can we say over here that if these two conditions are true, then if A was parallel to C and B was parallel to A, can we say B is parallel to C also, right? Let's see whether they would ask us to find the reasoning or not. Moving with the next condition. The next condition in the question says QSR and EFQ. Let's see where is QSR. QSR, EFQ. EFQ. Do we see the formation of an alphabet F over here? Right? Whenever we have a formation of the alphabet F, we say if this line was parallel to this line and then these two angles were same, right? We say they are corresponding angles. Okay. So next one is EFQ. Where is EFQ? This angle WVX. WVX. This angle. What they are trying to say is this angle should be equal to this angle. And we know that if we have two parallel lines which are being intersected by a single line, then if this angle was x, then this would be x. These are vertically opposite angles. If this angle was x, then this would be x. These two are corresponding angles. If this angle was x, or if this angle was x for us, then this would also be x. That means all these four angles would be the same, right? But in this case, this angle, when corresponds to this angle, they both are exterior angles, right? Alternate exterior angles theorem, right? So the last condition that we have is, they're saying QSR, this given angle, and QSR goes with WVX, where is W, V and X, then these two will be same also, right? And they have a congruence, they are the same. Therefore, the property is known as transitive property of congruence. Agreed? So up till now, what we saw was like parallel lines, corresponding angles, alternate interior angles, alternate exterior angles. And we can also say transitive property of congruence. Okay, why congruence? Because if this angle was equals to this, and if this angle was equals to this, okay, I'll write it down. If angle F was equals to angle S, angle F was equals to angle S, these two angles were same, then angle F was equals to angle V. Okay, if these two angles were same, then angle S should be equal to angle V. Agreed? So these are the conditions for angles to be equal, right? Moving ahead to the next question. Any question up till now? Let's do one more example. Then let's do the questions from the test. Okay. They are saying we need to complete the proof. Question number 8. Okay, this is question number 8, and they're saying let's complete the proof for this given question. We have one pair of parallel lines in this. Okay, they're saying QT and RS are parallel. Can we see? Yes, we can see QT and RS are set of parallel lines. It's already given. The second thing they're saying is SRU is equals to approximate. This sign is approximate or equal, right? We consider it to be equal. So SRU, let's see, SRU, this angle equals to this angle. We saw this property. I told you we have a parallel lines, and whenever we are forming a butterfly, then the top angles would be the same and the bottom angles would be the same. These would be the bottom angles. Okay. Okay. They're saying angle Q is equals to angle S. Yes, they would be equal because we are forming a Z over here. Agreed? With parallel lines. They would be alternate interior angles. Agreed? SRU, QT, SRU, where is SRU? SRU, sorry, is this angle, right? If this is SRU and QTU, QT and U is this angle. Same property as this, same. It's forming a Z, two parallel lines. Agreed? And this is the line intersecting. So can we say that Z formation is here? So this angle must be equal to this angle. And the next one they are saying angle Q, this given angle QTU should be equal to this angle. That's why if this was X, then this was X. If this is X, then this is X. If this is X, then this would also be X, right? That's alternate interior angles theorem. Okay, no, sorry. That was previous. This would be transitive property of congruence. Sorry, my bad. Transitive property of congruence when A equals to B and B equals to C, then A equals to C, right? That is transitive. From one, it means transition from A to B and B to C. Okay, the next one we have is angle S, this given angle, and QTU. This QTU or QTR is exactly the same thing. Okay, this is again the same thing, right? The two angles at the base. We say this is again transitive property of congruence. Okay, we can still say they are exactly the same. Okay, let's try a question from the test so that we do not leave the test. Okay, just a minute, please. Let's have a look. Meanwhile, I'll re-log in. I was not using the page. 26.7, chapter 26, lesson 7. Okay, maths, grade 10. That was 26 and 7. So let's do the test. So the first question that we have is complete the proof that this is given to us. In this case, we will just look at what they're asking us, only the last condition. Okay, so we are doing question number 1 from the test. This is question number 1 from the test that's given on the website. Okay. Okay. So the first question says we are given these two conditions. That could be the possible answers. And we have these statements. Okay. Let's see. Parallel lines. If line A, we can say if this line A, B, and C, if A is parallel to B and B is parallel to C, then A is parallel to C, right? These would be the conditions. What we need to find is whenever the last statement Vx, the line Vx, the line B is parallel to, okay, the line, sorry, I'll highlight, Vx was this line, right, was parallel to SU. When we're talking about parallel, it would have the word converse or convergence, right? Congruent and converse, right? So can we say over here, this statement would be converse of corresponding angles postulate, because they are also corresponding angles. If this was X, then this is X, this is X. If this was X, then this would be X, this would be X, or this would be X, right? So the correct option for this would be converse of corresponding angles postulate. Okay. Let's look at another question. Question number 2. They're saying complete the proof that the two angles QSR, I'll just copy, just give me a minute, please. They're saying we need to complete the proof for this, where the given conditions, given answers are these two, and the statements given are these. Okay. So for question number 2, we can say that we have three parallel lines, right? So what we can say is, what do we need to prove? We need to prove that QSR, where is QSR? QSR, this angle is equals to WVX, WVNX. These two angles are equal, right? So how can these two angles, this is the condition over here. So how can these be equal? Whenever we have these angles given, we say that if this was X, then this is corresponding X. This would be X. If this X, then this is in uh, vertically opposite angles. This is X, then this would be X, right? So we say that this is the transitive property of congruence, okay? So we click on the correct option. Very less questions, okay? So just give it a try, do the remaining questions, okay? And if you do it incorrectly, it would give you the correct answer, okay? Till I see you for the next class, best of luck, take care, bye.